is summarize what we've done the past couple days. So, first thing, we're going to talk about logs here, and we've been going back and forth between quite a bit between where we said our bases are the same. So if we had 3 squared equals 9 as a log, it's log base 3 of 9 equals 2. One thing to add here, a is always going to be greater than 0, and when a is greater than 0, x will be greater than 0 as well, so those are going to have to be positive. Common logs. Common logs. A lot of times we see that subscript number, but if there isn't one written, if it was just log of 5, you assume that base is 10, and base 10 occurs so frequently it's just not written there. So these properties, these go over what we did yesterday. If we have 2 logs added together, that equals when we multiply. So we have log base 2 of 30. If there was a division, or excuse me, subtraction, log base 2 of 6, log base 2 of 3, then we can divide those. So this would be log base 2 of 2. And if there's an exponent, we can bring it out in front. So log base 2 of 5 to the x power, that x can come out in front, and we have log base 2 of 5. And then this last one, all it's saying is if we have a log, if our base is a single log on each side, the bases are the same, well then 5 has to equal x. So the first thing we're going to do is we're going to write this as a single log, so we have to condense it. So we'll use those properties. We got adding, subtracting, and this number out in front. Well, we're going to take care of that first. So that's to the 1/2 power. Well, we know 36 to the 1/2 is 6. So log base 2 of 5, log base 2 of 6. And now since these are adding, we'll read it left to right with adding and subtracting. These two, we can go back to multiplying. And then we know subtraction goes to division, so log base 2 of 3. Single log again, well this is out in front, so we can put it as an exponent. So now that would be 9. So we have log base a of 6, log base a of 9, log base a of 10. Adding goes to division. We got 54. And then that would go, or adding goes to multiplying, excuse me. And then we have subtraction, so that would go to division. So log base a of 54 divided by 10. Solve. Well, this is going to use that one property that we talked about where we said if there's a single log on each side, then x would have to equal 5 in that case. So we need a single log. Well, adding goes to multiplying. So x times x plus 1, log base 11 of 6. So our logs are the same. So x times x plus 1 has to equal 6, because those bases are the same. So we have x squared plus x equals 6, subtract it. Well, we have a quadratic, okay? So we can factor that. I notice it's x plus 3, x minus 2. So our answers, I have x equals -3 and x equals 2. But when we double check it, if this was -3, we said it can't be negative because if you were just to evaluate this, we'd say 11 to some number gives you -3. Well, that's not possible. So it can't be the -3 because we can't have a -3 and this would be -2 in there. So our answer would just be x is 2. Solve this. Well, let's get a single log on each side. Adding goes to multiplying.